Hi, my name is Ernest Young, and today I wanted to talk about whether it's better to hand write your kernels in CUDA C++ versus Python JAX. And so we're going to compare a number of implementations in CUDA C++ versus Python JAX using the same attention map, the attention map being the attention mechanism from the transformer architecture. We're going to use our same humble 3060 and then we're going to use the same shapes, which is basically the number of blocks and threads that are being launched. And we're going to compare all these implementations. So we'll start with what I call scalar for FlashAttention 2. So here we're using shared memory in the tiling pattern, and we get the longest runtime for completing the mathematical operation at 151.1 milliseconds. We do better with WMMA, that's the warp matrix multiplication accumulation, and we get 52.1 milliseconds. That's in thanks to the fact that in one instruction, we do 16 by 16 mathematical operations, as opposed to in Scalar, we do only one mathematical operation per instruction. And then we do the best with using NVIDIA's CUTLASS linear algebra library. For Python JAX, let's start with the handwritten version of FlashAttention 2 that gets 74.4 milliseconds. And then we do better with using the built-in version of the entire attention mechanism in JAX and changing the underlying engine that it runs with, whether it's XLA or cuDNN. All right, comparing CUDA C++ versus Python JAX head-on, then again, we get the slowest operation with scalar CUDA, which is the FlashAttention 2 with just shared memory and tiling. Then that gets readily beat by Python JAX for FlashAttention 2 handwritten. And then that also gets beat by WMMA. That's written in CUDA C++, and then cuTLASS. That's also handwritten in CUDA C++. And then the one that does the best is Python JAX, but for its built-in version of attention mechanism, but using the underlying cuDNN as the engine. So another thing I want to point out is for the Python JAX numbers, we run it at least 3 times before so that both the computational graph is cached and the implementation or the compiled binary is cached. So then we are just running, we are measuring the time for the mathematical operation to take, and none of that time is with compilation. And hopefully in the next video, I want to talk more about performance benchmarking. Thank you.